The changing of the seasons is a natural phenomenon that affects weather, ecosystems, and daily life on Earth. While it might seem simple, the science behind the shifting seasons is fascinating and driven by the interplay of two key factors: the tilt of Earth's axis and its orbit around the Sun. Let's explore how these two aspects work together to create the cycle of spring, summer, autumn, fall, and winter. The tilt of Earth's axis. Earth is not perfectly upright as it orbits the Sun. Instead, it is tilted at an angle of about 23.5 degrees. This axial tilt is the primary reason we have different seasons. The tilt means that different parts of the Earth receive varying amounts of sunlight throughout the year. Key effect of the tilt: more sunlight in summer. When a hemisphere is tilted towards the Sun, it experiences summer because the sunlight is more direct and days are longer. Less sunlight in winter. When the hemisphere is tilted away from the Sun, it receives less direct sunlight, leading to shorter days and cooler temperatures. Without this tilt, there would be no significant change in seasons, and the Earth's climate would be much more uniform year-round. Earth's orbit around the Sun. In addition to the axial tilt, Earth also moves in an elliptical orbit around the Sun. This means that at different times of the year, the distance between Earth and the Sun slightly varies. However, it's not the distance but the angle of sunlight due to Earth's tilt that primarily causes the seasons to change. As Earth orbits the Sun, the orientation of its tilt relative to the Sun changes, and this creates the different seasons. Summer. The hemisphere tilted towards the Sun experiences summer. For instance, when the northern hemisphere is tilted towards the Sun, it enjoys longer, warmer days, while the southern hemisphere experiences winter. Winter. The hemisphere tilted away from the Sun gets fewer hours of daylight and colder temperatures. Spring and autumn, fall. These seasons happen when neither hemisphere is tilted significantly towards or away from the Sun. During these times, both hemispheres receive nearly equal amounts of sunlight, leading to milder, more moderate weather. Seasonal changes. Explained step by step. Spring equinox. Around March 21st, the Sun shines directly on the equator, resulting in roughly equal daylight and darkness across the globe. This marks the beginning of spring in the northern hemisphere and autumn in the southern hemisphere. Summer solstice. Around June 21st, the northern hemisphere is tilted towards the Sun, making it the longest day of the year. This is the start of summer in the northern hemisphere and winter in the southern hemisphere, where the days are shortest. Autumn equinox. Around September 23rd, the Sun again shines directly on the equator. Like the spring equinox, this creates nearly equal day and night, signaling the start of autumn in the northern hemisphere and spring in the southern hemisphere. Winter solstice. Around December 21st, the northern hemisphere is tilted away from the Sun, experiencing the shortest day and longest night. This marks the beginning of winter in the northern hemisphere and summer in the southern hemisphere, where the days are longest. Impact of the seasons. The changing of the seasons has a profound impact on life on Earth, influencing weather patterns, agricultural cycles, ecosystems, and even human behavior. Here's how. Weather patterns. The tilt and orbit of Earth creates cycles of warm and cold, dry and wet, depending on the season. This leads to the formation of seasonal climates like monsoons, dry summers, or freezing winters. Ecosystems and wildlife. Plants and animals have adapted to the changing seasons. For instance, many animals hibernate or migrate during winter to avoid the cold, while spring brings new plant growth and reproduction cycles. Human activities. Agriculture is heavily dependent on seasonal changes, with different crops being planted and harvested at specific times of the year. Cultural and religious festivals are often linked to the seasons, such as harvest festivals in autumn and winter holidays in colder regions. Why is the tilt 23.5 degrees? The exact reason why Earth is tilted at 23.5 degrees isn't fully understood, but scientists believe it is the result of collisions with other planetary bodies during the early formation of the solar system. These impacts likely knocked Earth into its current tilt, which has remained relatively stable over billions of years. Variations in seasonal intensity. Not all regions on Earth experience seasons in the same way. The intensity of seasonal changes depends on latitude. Tropics. Near the equator, seasonal variations are minimal. The temperature remains relatively constant year-round, with changes mostly in rainfall rather than temperature. Polar regions. Closer to the poles, the seasonal changes are extreme. In summer, The sun remains above the horizon for 24 hours a day, known as the midnight sun, while in winter, the sun doesn't rise at all for weeks or even months, known as polar night. Temperate zones. Between the tropics and polar regions, most of the world's population experiences four distinct seasons with significant temperature change. Over thousands of years, small changes in Earth's orbit and tilt called Milankovitch cycles can affect the intensity of the seasons, contributing to natural climate variations like ice ages. While the cycle of seasons remains stable in the short term, human activities like climate change are influencing the weather and altering seasonal patterns.